Hello, everyone. Today we will discuss cloud in perspective of IoT, and this is part of uh, lecture 13 of Internet of Things. The cloud, the soul of any IoT system. So cloud is very important, and at one end we have physical devices, physical world, and on the other end there is virtual world. The cloud is the main part of the virtual world. So, and these two lies at extreme ends of IoT interconnect IoT system. And cloud is a remote server that hosts applications, services, and platforms to provide services and solutions within an IoT environment. So the cloud will provide the storage, and it will provide different types of applications. Even it will provide an environment where you can develop codes, and some cloud system like Amazon, and there are some others as well. They even provide analytics tools for machine learning. So cloud is an important part of IoT, and when we connect our IoT system with cloud, so with the help of cloud, you can interact with your system anytime uh, and from any place. You can see, you can interact remotely with your system. The IT devices producing this data may be located anywhere around the globe, so a cloud must be able to connect, communicate, and direct data and information on any time, any place, and anything basis. So within an IoT ecosystem, there could be billions of devices which could be generating gigabytes or terabytes of data at any time. So uh, we know that in IoT we are facing huge number of data. Uh, the the big data, uh, the real sense of the big data we can envisage in IoT system. When the sensor is sensing and sending device in every second, and you have 100 of sensors, let's suppose, then you can imagine that how much data would be there. So the data from these billions of devices could have great deal of diversity and volatility. So the sensors and the devices are heterogeneous. The data types would be different, the formats would be different, the data, the sensor range would be different. So you will have diverse and volatile sort of volatility sort of data. A cloud must be efficient. So what should a cloud do with those? A cloud must be efficient enough to handle such scalability in such huge amount of data and diversity of data, and be able to produce useful insights from that data in real time. So the cloud must be efficient so that it can deploy its tools on those enormous data, huge data, and this, to tackle the scalability and do some analytics tools and analysis to find patterns or predictions using machine learning. So these are called insights. Uh, and those all things should be run in real time. So that cloud would be, we would say, is responsive, robust, and efficient. Responsible as a server, cloud needs to be more robust and responsive. The storage, processing, and analysis of data on a cloud to derive useful insights are collectively known as cloud computing. So, basically, the cloud computing consists of storage, data storage, and the processing, and then analysis of the data to get useful insight. And this is collectively known as cloud computing. The major activities in cloud computing involve delivering data, applications, photos, videos, and much more things over the internet to the cloud. Cloud computing acts as a paradigm for big data storage and analytics. The real evolution comes from combining IoT with cloud computing. So, the combination of IoT and cloud enhances the efficiency and the applications and make it more robust, intelligent. You know that alone IoT is not enough because it has limitations, it has restrictions in in memory, in processing. So to keep that huge data, we couldn't find any other device except the cloud. Otherwise, you have to buy a storage, another computer that can store that huge data. So, for example, sensory data can be uploaded and stored with cloud computing, later to be used intelligently for smart monitoring and activation with other smart devices. Cloud computing in IoT features rapid elasticity, which means that user can readily scale the services to their needs. So, uh, there is adaptive natures. You can change it according to your needs. If you need more storage, the cloud will provide more storage, and that can easily and quickly edit the software setup, add or remove users, increase storage spaces, etc. These characteristics further empower IoT by providing elastic computing power, storage, and networking. So, IoT cloud challenges. Uh, the cloud IoT cloud should be accessed anything, any place, and from any time. A cloud must have the following capabilities. Number one, it must be capable to access, store, analyze, process, and monitor big data. So this ingredient is essential. A cloud must provide this facility to capable to access data and store it, analyze it, and it give you a facility to monitor it remotely at any time from any place. And data must remain secure and protected on a cloud. So this is second important point, that the cloud must secure your data and protect it in the cloud. The cloud must be capable of providing inter-service and inter-device communication. So it is the cloud that is responsible to manage devices and manage data sharing and exchange among the devices. It is also responsible to synchronize data communication between the devices so that an IoT application could be successfully executed. So the IoT, the cloud should be responsible, or should be efficient. Uh, the correct word would be the efficient. So the cloud should be efficient to exchange data and provide uh, readily available for the devices, not only for the devices, but for the applications as well, like mobile applications or the desktop application. The cloud, despite all complexities, must be cost effective. Another reason, everything relate to money, so this should be cost effective, not too much expensive. Architecture of IoT cloud. So in this section we will see the architecture of the cloud, the components that constitute the IoT cloud. So you can see in the bottom there is a boundary, and above this you can see the IoT devices, edge layer. They are communicating with the gateway, and then from some communication network like Wi-Fi, it will send data to gateway, uh, sent to the cloud. In the cloud, the first element or component is called data ingestion, and then pipeline, data storage, and application and presentation, and data analytics. So we will explain those things in detail. So any cloud is designed to perform the following basic processes. Data ingestion. So this is the part where data is collected from the network and then put into cloud. So the data ingestion part is the place where data is collected into cloud from the network. It aggregates the data from IoT devices, it collects the data and distributes the data for further processing. It also works in reverse direction, means the data can also flow from cloud to the edge layer to the devices in a opposite direction. And pipelining. After the data has been collected in the cloud, it is the responsibility of IoT cloud to manage the data in a proper way. The process of pipelining includes several tasks. So in pipelining, we have to manage the data in cloud. And what are the tasks involved in data management? Number one is device registry. So every device would be registered with some ID so that one can identify that the, the data present in the cloud actually sourced from, originated from that device. So device registry and transforming data, sometimes that is not in a format, uh, so you have to transform that in proper format. For example, uh, you have a table of age and the data is coming into a date of birth. So in the age section you cannot put date of birth, so you have to do some processing and convert that date of birth into age. So this is just an example. So the data formation is also is a part of data management. And aggregating data and computing, data aggregation is responsible for increasing the network lifetime and reducing the energy consumption. For example, that aggregating means a single data that can represent a whole bunch of data. So instead of storing 100 values that comes in 1 minute, so if 100 values is coming in 1 minute from IoT devices into cloud, so rather than storing the 100 values, why you not doing average of those 100 values, and you will have a single value. So those type of things are called aggregating data and computing. So this increase the lifetime, network lifetime, and reduce the energy consumption, eliminating redundancy and decreasing the amount of transferred data. By combining data, you can add checks, such as averaging data across multiple devices to avoid acting on a single spurious device. You can ensure that you have actionable data if a single device goes offline. By adding computation to your pipeline, you can apply streaming analytics to data while it is still in the processing pipeline. Device metadata. So device metadata means the data about a device, like what is the ID and what is the range of the values that particular device can send. For example, you can say a thermometer, that you guys know that. So what is the minimum and maximum value? Let's suppose the minimum value is 0 degrees centigrade and the maximum value is 100 degrees centigrade. You have a thermometer like that. So this particular thermometer has a range of 100 values, 0 to 100. So this we can say metadata. So the metadata includes identification number that uniquely identify device. The device ID should never change for the lifespan of a deployed device. Class or type, model, revision, date of manufacture, hardware serial numbers, those are called device metadata. So enriching data. The data generated by a device can be combined with metadata. So a thermometer is generating a data like it says 23 degrees centigrade. And if you combine this 23 degrees centigrade with the metadata like this is this data 23 degrees centigrade came from thermometer number 1 manufactured by this company. The date of manufacturing is this. So this will give more information. So you can say this will enrich the data. So this enriching data is also a part of data management. Moving data. The process data can be passed on to be stored in one or more storage locations or caches. Data storage. This is the third component of a cloud, and the main purpose of the cloud is to store the data. So it's very obvious thing. Real-time data analytics. After the data storage, cloud platform can perform some kind of analytics on that data and convert it into a feasible action of human use for human use. Cloud platform analyze information and process the information with some kind of mathematics or logic or some algorithms, machine learning algorithm like KNN or K-mean or SVN support vector machine or deep neural network. So these are all analytics tools, and they give us some information about the data classes, or how many classes present in the data, and even it can predict as well. Application and presentations. The cloud, after processing the data, can send the data to other IoT devices to perform some tasks. Based on that, I can provide the data to other computing engines. So, and next is the services that IoT Cloud provides. On the basis of service natures, uh, the services are classified into three. Number one, IaaS, IaaS, PaaS, and SaaS. IoT Cloud as service provider. The cloud or the service provider in an IoT environment. There are many as a service roles of cloud computing. All these as a service roles are cloud services rendered by the cloud platform. So whatever services cloud provides, that comes into uh, infrastructure. So those are services. So infrastructure as a service, infrastructure as a service means the cloud provides infrastructure like hardware or communication, medium of communication technology. So those things called infrastructure IoT as a service. IaaS comes at the bottom of the cloud. So IaaS provider provides fundamental building blocks of computing resources to the clients over the internet, such as networking resources, hardware, software, storage, and many other IT infrastructure companies. IaaS provider grants access to all these resources to the clients. IaaS users pay on a per use basis. So mm, they will charge, obviously, uh, in one or another way. This is not free. The vendor provider is responsible for configuring and maintaining the infrastructure. So the one who is the owner of the cloud and providing this to client. So this is the responsibility of the vendor or provider to configure and maintain the infrastructure of the cloud. And some well-known IaaS providers are Amazon Web Services, Windows, Azure, and Google Compute Engine. Platform as a service. The PaaS provides a platform to the user to develop, run, and manage applications. So, like you have when you write a program, like for example, you are writing a program of Java in Eclipse. So the cloud will provide an environment where you can write a program in a particular language. So those tools will be provided by the PaaS, by the service of the cloud that is known as PaaS. PaaS is typically associated with developing and launching an app in a constrained environment. PaaS user manages application and data, while the provider handles the runtime, middleware, operating system, virtualization, server storage, and networking. Development tools provided by the IaaS are customized according to the need of the client. So PaaS allows for higher level programming with extremely reduced complexity at the user end. Some example of PaaS solutions are the Google App Engine, uh, Heroku, which operates on top of the Amazon Web Services, and Force.com, built as part of the Salesforce.com software as a service offering. So PaaS are those services in which provides you um, an environment where you can build your program, and it will give you compiling facilities. So all those sort of services comes under PaaS. Software as a service. So end user operates the top layer, as I show you in the picture. So end user operates the software applications only, like email, word processing, etc. So those facilities also provided by by the cloud. So the software, what software are those? It could be email, or it could be MS Word type editor, where you can write some text. So something like that. All right. So they do not need to worry about complex software development and hardware management. So the user do not need to buy those software. The cloud provider will provide those things. These applications run on the SaaS provider service servers. The user only requests to access them. The provider manages the access of the application and its security, reliability, and performance. So security, reliability, and performance is a part of vendor, and the user part is to access that and use them, rather than you can buy those softwares for your own. And so they are really available softwares on the cloud. Some of the most well-known SaaS providers are Google Apps, Microsoft Business Productivity, Online Suites, etc. Okay, guys. So this was our third chapter number 13 on cloud computing in, in context of IoT. If you guys have any questions, please let me know and subscribe the channel and write down the comments if you have any. Thank you very much. Bye.